right, this question can look a little bit challenging because they're asking us to solve for an awkward perimeter, and that perimeter is this really long string of letters here. And so if we follow this string of letters, we are going to find the perimeter of P to Q to W to T to U to V to R, and then close it by going back to P. So basically, we're finding the perimeter of the outside of these triangles where they don't overlap. And we're given some information about the triangles themselves in the original question stem. We're told that the triangles are identical equilateral triangles and that they have sides of length 6 because PQ is length 6. And since they're equilateral, that means all the sides of these triangles are length 6. So we know that the perimeter of each of these triangles on their own would be a perimeter of 6, 6, 6, which equals 18. Now, the only difference between having two of these triangles separate versus the perimeter that we're looking at now is this overlap, which is not getting counted. So the perimeter is not getting counted from here to here to here. So there's like a little triangle's worth of perimeter that is getting removed. So we know that 18 times 2 for both triangles would be a perimeter of 16 since we have two of them and they both have perimeters of 18. So it would be 36 for both of them. And we're removing some amount for this smaller triangle to get to a new total. And if we look at statement 1 says the triangle SWV has perimeter 9. And that is this little triangle, which means we are removing a perimeter of 9, which would make our answer solvable. So this is definitely sufficient. There's only one answer. Statement 2 says VW has a length of 3.5. Well, VW, V to W has a length of 3.5. Now, that means that from here to here and here to here is going to be 6 minus 3.5. But it doesn't guarantee how much this or this side contain in terms of length. So if you imagine if we draw that same base triangle, we could draw the other triangle in a way where it could dip more in while having the same amount of space taken off. And basically we wouldn't know how much of this, how much this side or this side are worth, depending on if we move the triangle around a little bit. So we know that, for example, this is a 60-degree angle because all the angles have to be, but depending at what angle we're hitting here and here, this could be like 110 and 10, which would add up to 180, or it could be 60, 60, 60. And also leverage the information you know about statement 1, which is the perimeter of SVW is 9. That's a factual piece of information. So knowing that, we know that this is not an equilateral triangle because if it had a perimeter of 9, that would mean it was sides of 3, 3, and 3. But statement 2 is telling us straight up that this is a side of 3.5. So we know factually this is not an equilateral triangle. And there is a possible situation where we would have an equilateral triangle and still be able to come up with sides of 3, 3, and 3, which would add up to a perimeter of 9. So just knowing this length is totally insufficient. Knowing that we have a perimeter of 9 total for that little triangle definitely is sufficient because this is all we need to do to solve the question. So our answer here, just to be clear, is answer choice A.